The following question reads that a dimer X is stable when solid, but a dynamic equilibrium is set up in solution. This is the reaction that's happening. X is changing into Y, and they're in equilibrium. And the question then states that the solution of X has an initial concentration of 0.5 mole per dm cube. So the initial concentration of X is 0.5 mole per decimeter cube. So this is my initial concentration. That's given, and there is no Y produced, so Y is initially 0. So that's the initial concentration, and when equilibrium has reached, X has fallen to 0.25 mole per dm cube. So X at equilibrium, once equilibrium has been reached, so equilibrium concentration of X is 0.25 mole per decimeter cube. So that's mole per decimeter cube. Now the difference indicates that if you look at the difference, initially you added 0.5, now you have 0.25, which means that 0.25 are missing, which means that 0.25 mole per dm cube reacted. So this is the amount that has reacted. So if 0.25 reacted, initially 0.5 added, 0.25 left at the end. So 0.25 reacted. So 1 reacts, produces 2. So 0.25 react, they're going to produce 0.5 according to the ratio. So the concentration of Y is going to be that 0.25 must have been produced. So your equilibrium moles, initially you had 0 moles. Now at equilibrium, 0.5 have been produced. So the equilibrium moles are going to be 0.5 mole per decimeter cube. So these are your equilibrium moles, and we can circle that. These are my equilibrium moles for X and my equilibrium moles for Y. The question then states the changes in X concentration, Y concentration are plotted against time until equilibrium is reached. The variation of Kc is the value of Kc is then calculated. So we need to calculate the value of Kc. Kc in this case is going to be the concentration of Y, and that is going to be squared. The concentration of Y squared divided by the concentration of X. Because Y is 2 moles, X is 1 mole, so Y squared. So it's going to be Y is 0.5, so that's 0.5 squared divided by 0.25. And if you solve this, this would give you a value of 1. So Kc has a value of 1. So you're supposed to figure out which one are the correct graphs. So Kc is 1 in this case, and if you move below, Kc is also 1 in option C. So you have a choice between option A and option C. Let's look at the graphs as well, because let's start with the initial concentration. Initial concentration of X was 0.5 and initial concentration of Y was 0. Equilibrium concentration of X is 0.25, for Y it's 0.5. So this is not going to be the correct graph, the first one, because the final concentration of Y is going to be 0.5, which is not true over here, because if you follow the plotted line of Y reaches up to 0.25 mark. So it's only reaching up to the 0.25 mark. So it's not going to be the correct answer. The graph is not going to be the correct one, because the final concentration of Y is 0.5. If you look at C, that is going to be the correct graph, because the concentration of Y initially was 0. 0.5 mole per dm cube were made up at equilibrium. For X, the initial concentration was 0.5 and it dropped to 0.25. So option C is going to be the correct option for this question.